In this video I'm going to have a look at the 2007 question 2b. So in the question we have a man who can swim at a speed of 3 meters per second in still water. Now one of the tricky things about this question can be the wording. If that's the speed he can, or velocity he can swim in still water, that's his velocity relative to the water. So that's the velocity of the man relative to the water. His actual velocity, or his kind of end velocity, would be his velocity plus the velocity of the river. So he swims across a river of width 30 meters and he sets out at an angle of 30 degrees to the bank. The river flows with a constant speed of 5 meters per second parallel to the straight bank. In crossing the river he's carried downstream a distance d meters. Find d correct to 2 places of decimals. So the first thing we want to do is we want to write our velocities in terms of I and j. So if this is the bank, the man is swimming at a velocity of 30 degrees upstream at a speed of 3 meters per second. Sorry, at an angle of 30 degrees upstream at a velocity of 30 meters per second. So if we wanted to write the velocity of the man relative to the river in terms of I and j, it would be minus 3 times cos 30 I plus 3 times sine 30j. And just be careful with your sign notation. We're saying here that the direction to the left is minus and to the right is plus. Type that into your calculator and you'll get an answer of minus 2.598i plus 1.5j. So this is the velocity of the man, assuming that the current is not flowing, the velocity of the man relative to the river. The velocity of the river is easy. It's just going to be 5i plus 0j because it has no component in the j direction. Now we know these two facts, so we want to figure out his overall velocity. What is the actual velocity of the man? Now the velocity of the man relative to the river is equal to the velocity of the man minus the velocity of the river. So the overall velocity of the man will be velocity of the man relative to the river plus the velocity of the river. So that's going to be minus 2.598i plus 1.5j plus 5i. So remember, we can only add the I terms and the j terms, so we can add these two terms, but we just have one j term, so we leave that the same. So the velocity of the man becomes 2.402i plus 1.5j. That's the velocity of the man. So now this is our single velocity that kind of takes into account both the velocity of the river and the velocity of the man relative to the river. So he's trying to cross a river now that is 30 meters wide. He's leaving from this point and his velocity is 2.402i, so it's about this much to the right and this much up. So it's something like that. That's his velocity. That's the velocity of the man. And we're trying to figure out how far downstream d he would have ended up. So remember, you just pick the velocities and the distance in one direction only. So let's say we look at the j, or this is the I direction, call this the j direction. If we look at the j direction, what information do we have? Well, we have the distance in the j direction is 30 meters. And we also have the velocity in the j direction, which is 1.5 meters per second. So because both of these are in the j direction, we can use them to figure out time. Velocity is distance or displacement over time. So time is displacement over velocity. So 30 divided by 1.5, which equals 20 seconds. So what we figured out there is it takes 20 seconds for the man to go from this side of the river to this side of the river. So now we can use that 20 seconds because that's the same as the time it takes for the man to get from this part of the river downstream to D. So if we look at the I direction then, well, we know the time is 20 seconds. That's how long it takes him to move down the river. And we know the velocity in the I direction is 2.402 meters per second. So now we can use this to find the I displacement. S will equal V times T, which is 2.402 times 20, which works out at, well, 48 point something meters. 2.402 48.04 meters. And that's your answer. So really easy question once you kind of understand the fact that you need to split everything into I and J, and once you get your kind of velocities right here at the start.